Yeah, hello everybody, macroeconomics again. And last week we started in our general overview of the general variables in an economy with, the main good of exchange, the main good which we use in developed economies. We started to talk about money. What is money? And that money is not just euro or US dollar, but money defines itself via its properties, via the things what we are using money for. And then from this, we also talked about from the properties, about the functions of money. And then, since later on, when we are talking about theoretical models, we will have also a look on the so-called money market. Um, and for this, we talked about the motives of holding money in order to in order to derive something like a money demand function. And from these three motives, transaction motive, precautionary motive, and speculative motive, we derived this general dependence that we assume a positive dependence on income, and from the speculative motive or also from the argumentation via opportunity costs, a negative dependence of money demand on interest rates. And then, of course, as we talked about this topic, looking on GDP and the difference between nominal and real GDP, we also talked about the concept of real interest rates and nominal interest rates. That, if we are investing, we are not only happy if we have a high rent, a high interest rate, but we are interested in the question, can we really buy in the future then also more goods and services after the liquidation of our investment? And this means that we also have to look at the future development of inflation. And this was then the so-called Fisher relation, where we obtain mathematically exact the dependence between the interest rate factors, 1 plus real interest rate equals 1 plus nominal interest rate over 1 plus inflation rate, the inflation factor. Or if interest rates and price development is not too volatile, roughly you can think of, if these numbers are smaller than 10%, then we can approximate this relation with the maybe better known dependence that real interest rate is just the difference between nominal interest rate and inflation. But be careful, just 2 years ago, we had, even in Germany, inflation rates larger than 10%. And especially you are studying international economics, if you look especially at developing countries or countries which we call, which we announce the so-called emerging markets, that there you quite often find two-digit inflation rates and also two-digit interest rates. Look, for example, at Turkey. There maybe we have roughly inflation rates about 50 or 100%. And if you look at the interest rates there, they are, I think, around 20% or something like this. And then, of course, we cannot use this approximation anymore. And also quite often, we are looking into the future, and then asking, is our real interest rate positive or negative? Then we calculate the difference between nominal interest rate today and our anticipated future inflation rate. Okay, this was the Fisher equation, and yeah, we had until this point talked about the general concept of money, and now we more or less want to talk what is money today. So what is the euro? What is the US dollar? And in nowadays in our world, we are, and about this I have talked when we looked at the magic square, especially at the external balance, we are not anymore in a situation where we have a so-called physical anchor of money. Remember when we talked about the properties of money, which good do we find all over the world which has all these properties? This is gold, and for a long time, and especially when the modern economies have developed during the Industrial Revolution, especially in the 19th century, there all central banks they they said, well, we have our gold reserves, and in general, if you have a German Reichsmark or a British pound or a French franc or a US dollar, you have always having this piece of paper or this coin, you have the right to exchange your money into gold. This was the promise of the central banks in general. And firstly, until the Second World War, this was called the gold standard. And then came the turmoil in the 1930s and the Second World War. And after World War II, we had for roughly 20 years the system of Bretton Woods. Bretton Woods is a small village just outside Washington, D.C. And there it was formed the general concept that one had fixed exchange rates of every convertible currency. So the currencies of the Western countries, because we had then the opposite blocks in the world, the Soviet Union bloc with especially Eastern Europe and the Western bloc. And these Western countries, they promised that they fix their exchange rate of their own currency, so of the German marks, versus the US dollar and the British pound versus the US dollar. And so that even if you are not a US citizen, due to the system of fixed exchange rates, you also had the right to change your own currency into US dollar and then going with this US dollar to the US central bank and exchange this into gold. And maybe you have seen I think the first or no, the second James Bond called Goldfinger, and this was just about yeah, the explosion of maybe an atomic bomb in Fort Knox, where the US gold reserves were situated. And the idea behind this was, well, that you then can blast the financial system of the world and be the master in chief. Well, this system was then laid down, and now We have a system of totally flexible exchange rates. So every day or even every minute, every second, the exchange rate of the currencies are fixed to a new number. So we have an exchange process, just a free market process, which is changing every day. And yeah, what is then modern money today? So with 10 euros in our pocket or 1,000 euros at our banking account, we have no general right anymore to go anywhere and say, well, you must give me something in exchange to this money. And this we really have to keep in mind, especially in these very, yeah, how should I say, very volatile times. If we look at the policy which is made in the United States, in China, and also, yeah, we are not in the in a very stable political situation right now. And what money is then, or what money is now in modern times, is just a promise that I can get something in exchange to this money. So the central banks handing out the money, they only promise that you obtain something in exchange. But there is no right anymore that I get something. And the reason why this works is more or less that we trust in ourselves. In the end, we, the citizens of the countries, are the owners of the central banks. So more or less, we give to ourselves a promise that the system is working. Well, and of course, the system can only work if our countries are stable. If Germany exists also tomorrow. And this we really have to keep in mind, especially in times which we have right now. That we rely on the stability of our countries. And therefore, we call money today just fiat money. Is here anybody who had Latin in school? Because this is Latin. Money is, of course, English. Money and fiat. Maybe some Christians are in this class. Then you know the Pater Noster. There you have the sentence fiat voluntas tua. Your will be done. So fiat is Latin and just means it is not a car, it is not an Italian car. It just means Latin, it will be money. It will be money. We just print this, we just print something on this paper and then we just say it is money. It is created out of our own trust in the stability of our countries, of our central banks. There is no anchor in behind anymore. So it is just created via the process that we say that it is money. Yeah, and if we then look at what is understood if we see in the media the monetary base is increasing or the money amount is increasing or has increased the last 2 years by 3%, then we really have to define what is then understood by money. And of course, we have our cash. There we just argued the central bank is starting to print money and giving out cash. Well, if we look at the institution of the ECB, then surprisingly we do not find this, I call it M0, this so to speak first kind of money. Well, and maybe you can also understood why we are not defining this cash, because think of yourself. How often are you paying with cash relative what you are doing every day, every month? I don't think that you pay your rent, for example, in cash. Maybe if you go to a restaurant, even if you are buying your clothes, I think you are very rarely paying with cash. You're taking your credit card, you're taking PayPal, you're doing something else. And therefore, then we say, well, if we want to define what is modern money, then we have to look what are we using as money. And there's, of course, we are using as money as in good for exchange our credit card, our banking account card, or if you are paying at Amazon or via PayPal, then creating your Amazon account in order to pay, or creating your PayPal account in order to pay, then in behind you have your banking account. And so, and this is then defined as the monetary base, M1 is defined as all cash, so the sum of currency in circulation, and overnight deposits. So this is your private banking account. And this is mainly behind your credit card, your PayPal account, Apple Pay, and so on. And what does overnight deposits mean? Like you can always go to your bank and take out all what you have in your banking account. You have the right. If you have, let's say, 3,000 euros at your banking account, you can, in 1 hour after this lecture, go to the go to your bank and you can take your 3,000 euros. And therefore, overnight maturity. Well, then we can think what are we using further as a medium of exchange. So think of the situation you have on your overnight deposit, on your general private banking account, 3,000 euros. And now you want to buy a car for, let's say, 10,000 euros. You do not have this 10,000 euros at once. But maybe you have another banking account or investment with a little longer maturity. Let's say with a maturity of 6 months. So you cannot get it today, but you can get this money, let's say the other 7,000 euros you need, you can show the car seller that you can pay him in 6 months. You show him this longer term banking account, that the money is there, but you cannot get it today. And then you can think of that you, although you do not have the money today, you can nevertheless get the car today, because you make a contract that you hand over directly cash of 3,000 euro you can get today, and then you say, well, the rest, the 7,000 euros you will get, I have showed you, I'm liquid in 6 months, you will get in 6 months. And such exchanges are made quite often. And therefore we say, well, so although you have not this money today or directly or overnight, you can nevertheless use this kind of deposits in order to use it like money. Because you can exchange this into real goods. You get the car today, although you are paying in 6 months. Yeah? So you are using it like money. And therefore then we say, well, as we started when we talked about money, everything is money, what is used as money. And then it is defined that we take deposits with a maturity up to 3 months, up to 2 years roughly. And this is then called M2. And then think of the circular flow. There we had the sector of the financial institutions. And think of when if insurances or bankings with each other are changing things, are exchanging investments. They are doing their really, really large amounts in an amount of millions, billion euros, US dollars. Well, and they are not exchanging always cash. They exchanging financial products. And especially these financial products which are exchanged in the financial markets by the financial institutions, this sind so-called repurchase agreements, money market funds and shares, and debt securities, and also roughly with a maturity up to 2 years. And then adding these kinds of financial products used in general by the financial institutions. Adding this to M2, then we are at the monetary aggregate M3. And if you are reading in the media about the money amount is evolving over time, increasing by 3% over the last year or something like this, if nothing else is said, then in general M3 is meant. So this is the general definition of money. Of modern money. So I don't know if somebody of you is already participating in the modules or in the lectures of the financial topics or so. There, I think you will talk in more detail about these products when you are going more deeply into the financial markets. At this here in the introductory course of macroeconomics, I give only the overview that you already have heard about this. So, and then let's see how much money do we have, especially in the Eurozone. And this is the latest data. I found that in August 2025, we find at the ECB, source should be here, that we have roughly 17 trillion euros measuring M3. Well, and what we see here especially is that we had a general increase, and then here it was flat during the financial crisis due to the bad economic performance. During this time, we didn't really need more money. But what we want to talk about is now, is this a reasonable number? Why is it roughly 17 trillion euros? Why is it not only 2 or why is it not 50? And there we think of GDP. Hopefully you remember what is GDP of Germany. Do you remember? Nominal. What was nominal GDP of last year, 2024, of Germany, roughly? Yes, 4.3 trillion euros. Well, and then hopefully I can draw it quite okay. Let's say. So this should be Europe, hopefully. So here somewhere is Germany. And this is then Italy, Swiss, Austria, France, Portugal, or here you have, of course, UK and Ireland. And let's take it in blue. What are the member countries of the European Monetary Union? Yep, also France. So this one, Germany, Spain, Portugal,
Slovakia.
Netherlands. This would be somewhere here. Netherlands, Belgium, Luxembourg. Yep. Yes, these three countries here, Latvia, Estonia, and Lithuania. Yes, these countries. And
Slovakia as well.
Slovakia, this would be then somewhere here. Slovakia, this was set in the internet, yeah.
And from the next year, Bulgaria as well.
Bulgaria, yes, then Bulgaria next year. And then, pardon? Italy, of course.
Finland,
Finland, yeah, Finland is then here.
Croatia,
Croatia, yes, this one. No, not Sweden. Also not, no. But then we have also Ireland, then Greece down here, and Cyprus, Malta, and Slovenia also here. I think that it was. So, and now, if we know the German GDP, could you maybe roughly, now knowing which countries belong to the European Monetary Union, what is roughly GDP of the EMU, European Monetary Union? Maybe you know that Germany is the largest economic bloc of the European Monetary Union. So we have the largest GDP of all member countries. Think of the demand side or the expenditure side of GDP. There we already argued that we have another variable which is highly correlated with the GDP, and where we can say when we have the relative number of this number, then we can also say um, maybe France is 80% of GDP of Germany. Which other number did I have introduced when you think of the expenditure of the demand side of GDP? Then we are consuming. And who is consuming? We are consuming. So every human being is consuming, and therefore I have argued the higher the number, the number of inhabitants of a country, roughly the higher is the GDP. And if we now assume, of course, this is not in general true, but roughly we can say that within the European Monetary Union, we have a roughly same level of welfare so that it is not too volatile. Then we also can assume that every member in the European Monetary Union more or less consumes roughly the same. So that a Greek person consumes roughly the same as a German, as an Irish, as a Spain person. So how many inhabitants has Germany? Population?
86 million, 85 million, close
Yeah,
to.
so let's say roughly 80 million in order that the numbers are easy. So I think it's right now 84, 80 million. What is the number of inhabitants of the European Monetary Union? This you can also look up. So France has roughly 65, Italy 60 million, Spain, the fourth largest, I think roughly 35 or 40 million. And adding all these up, well, let's have a look. where is it? There, population of EMU. Oops, European Monetary Union. So roughly 350. So Germany has a little bit more than 20, almost 25% of the population of the European Monetary Union. And this means by a rough approximation, we can say that roughly the GDP of the European Monetary Union is roughly 4 times higher than the German one. So from this, GDP of EMU should be roughly 4 times GDP of Germany. So maybe 15 to 16 million euros, because also maybe you know that the standard of living in Germany is a little bit above average. So people, especially in Portugal and the eastern ones, they have a little lower, also in Italy, as one of the large members of the European Monetary Union, is a little bit below the level of Germany. So maybe then not at all times 4. So let's see. I do not have it in my head. What is GDP of the monetary? GDP 2024. I hope that I'm roughly right with my estimation. US dollars, I want it in euro. This is a growth rate in euros. But it looks quite good because right now we have an exchange rate, I think, of 1.1. So then it's dropped a little bit. So not bad. The number is actual number. What do we have here? Roughly 12.2 trillion euros. Well, and now maybe the number here of 17 trillion euros does not surprise us very much, because it is roughly the value of nominal GDP of the European Monetary Union. Because why is it not surprisingly? Well, we are using our money in order to buy everything what we have produced. So, and this you can maybe also keep in mind, that the amount of money roughly corresponds to the value, nominal value of GDP. And behind this correspondence, it is not exactly one, but it is roughly a correspondence. This is the so-called quantity theory of money. And again, we look at the things which we are doing with money. Because then we say, on the one side, we have the total amount of money, and we multiply it with the so-called velocity of money. Because if I take here my 10 euros, I buy today some breakfast. Then, of course, tomorrow the bakery takes this 10 euros and buys some other things. So within 1 year, the same euro circulates more times. With the same euro, we are buying. We are buying not only once, we are buying more often. And how often we buy with the same euro within some specific time period within a year, this is called the velocity of money. And there we say, well, this velocity of money is in the short term quite stable, because this, of course, also depends on the framework, on the infrastructure. Think of, I don't know, maybe you are born roughly in the beginning of the millennium, I think. 2000, 2001, 2002, or something like this. And if you think of you as a child in 2008 or something, maybe you can remember these times. In this time, there was no PayPal. There was no Apple Pay and other possibilities, or there was even, this was the starting point of the iPhone. But you couldn't just take your phone, put it in the supermarket, and then paying with this. So all these innovations, these technical innovations, they, of course, also over time increase the velocity of money. But let's say over 5 years or something like this we can say it, since it depends on the infrastructure, it is roughly stable. It changes over time, but it changes slowly over time. So every euro we have times the velocity of money. What are we doing with this money? Well, we are buying the things. Think again about the expenditure approach of GDP. So we are paying all the things we are buying. So this should be then price level in the aggregate view times real output. And we also have talked about the development of real output over time. And there, especially in developed countries, we said, well, we are quite happy if we have an increase of 1 to maybe 3% per year. And nowadays in Germany, we have even lower, or we have even a decrease in real output. So also we can say that in the short run, this number also changes very slow, or only a little bit. And then at a first approximation, we also can say relative to a price change. And think of the inflation rate is announced every month. And we see that the price, the inflation changes every month. So it changes quite fast. That in the short run, we can roughly also assume that this number is more or less stable, is fixed. Also this number. So if this number and this number are only changing slightly, then this argumentation via the quantity theory of money just says that we have a proportional dependence between the amount of money and the price level. And taking this now, we can rearrange this dependence. M is money, velocity of money, price level, and real output, dividing by the velocity of money. We are left on the left side with the amount of money. Here is real output. This is what we want to buy. And now again, think of the transaction motive. Then everything what we are producing, we want to buy. For everything what we have produced, we need money. And therefore, this dependence then can be also interpreted as a money demand function. That M equals MD, D is demand. And then in general, this division by the velocity of money is defined as the so-called cash holding coefficient. That then we obtain money demand equals a fixed number, 1 over velocity of money, the cash holding coefficient, times price level, and this is the important one, times the real output. And now we can also interpret again this output, what we have produced, from the other side, from the expenditure approach. Then it is income. And we end up then with a money demand depending positively on income. But in this case, we only have one dependence of money demand. So here we have only one variable. And compare this with the other one, which we had here. Here we had also the dependence on interest rate. If we only assume this interpretation of for what is money used via the quantity theory of money, we end up with another money demand function where we do not have an interest rate dependence, where we only have the income dependence. And this is then called the so-called neoclassical demand function. And I will come later on in our theoretical models then once we are using the Keynesian, in the Keynesian model, money demand function. And if we later on then talk about neoclassical models, then we apply the neoclassical money demand function. Well, using these absolute values here, we can also take this dependence and then calculating from this via the total differential the dependence of the growth rates of these variables. And let's do it. Hopefully you have done this in your mathematics course. For this, we take the log of both sides. So we start with m times v equals p times y. And now we take the log of both sides. What do we have then? Log of m times v equals log of p times y. What is the main functional property of the log function? So how can I rewrite log of x times y? This you should have done in school and hopefully also in your introductory course of mathematics. What is the main functional property? And this is a really nice functional property because multiplying two variables is always quite complicated. What is easier is to, yeah, do you have an idea? Yes, is if we have just a summation. And the nice property of log is that a multiplication translates into a summation, which we can handle much easier. Is ln x plus or log of y? Yeah, no matter. So, and now we are interested, we want to come to the growth rates, so we are interested in the change of the variables. And for this, we are taking the total differential. What is the total differential? Well, we have here four variables. And the total differential is something like the general if we derive in general a function. So it is a general derivative. Think of you have done, I think in school, f of x is x squared plus square root of x maybe. And then you said, well, f prime, since I have only one variable, is 2x plus 1/2 1 over square root of x. But of course, in economics, we very, very often do not have only one variable. We quite often have many variables. And then we can think of, well, what is the general derivative of a function? And there one has different concepts. You have also a gradient, but we want here to simultaneously look at the change of all variables. And then this is then written as d. This is the differential operator of, and now I take this possibility that I can just write down this as a summation, log m plus log v, and the change of log p times log y. And this means now that I should take the derivative of every variable. So if I have f of x equals log x, what is the derivative of this function? What is the derivative of the log? Almost. So the derivative is just 1 over x. Yeah, it's coming. Okay. So, and this operator here means take the derivative of the function times the change of the variable itself. So log m, the derivative is 1 over m times just the change of m. And the change, there we write dm, or as I written it here, delta. So this then means we obtain just delta m over m plus delta v plus v times delta p over p plus delta y over y. Well, this is the growth rate of money. This is the growth rate of the velocity of money. There we have assumed that is in the short run constant. So this is then more or less zero. This is inflation. And this is again our real GDP growth rate. So in general, if we assume that the velocity of money is again constant, we obtain that inflation is equal to the difference of the monetary growth rate minus the economic growth rate measured by real GDP. And if we assume then that real GDP growth is maybe 1 to 3%, then of course we need in these economies, since the amount what we are producing is increasing over time slightly, we also need a slight increase of our monetary base. And if you then think of an inflation target of roughly 2%, then this monetary growth rate should be then somewhere in the neighborhood of 3, 4, or 5%. But on the other hand, if this growth rate is increasing too much, if we really start to print money, and there the politicians, of course, they have the incentive. Look at Mr. Trump. He really tries to push the Fed to decrease interest rates, to increase, to print money, to give out money in order to push the economy. Then you have, due to this concept of the quantity theory of money, be very careful, because if this increase is now 6, 7, 8, 10%, then this would mean I have this one-to-one property on the price level. That printing money just means increasing inflation. And there is one very famous quote of Milton Friedman, one of the first Nobel laureates in economics. And he said, well, if we see quite high inflation rates, that then this is always and everywhere only a monetary phenomenon. That you just have to look at the development of your monetary aggregates, and that this mainly influences inflation. But of course, this is a quite fixed view on the economy and on the working of economy. And if I really assume that this is the right model, then we obtain the so-called classical dichotomy. And this means then that we have a decoupling between nominal variables and real variables. So the real variables, about this we have talked much when we talked about economic growth. These are our physical units. These are our quantities. And there we look only not, whoa, this is expensive because it costs 200 euros. No, we always have to look relative to the price of some other goods. So not the nominal value or the nominal price is the relevant, but the relative price. What is the price of the other goods? And this defines then the exchange rate of these two physical goods. If one good costs 200 and the other one costs 150, then it's almost a one-to-one relation. So only the relative prices are the relevant if we look at real variables. And so not that I am earning 100,000 euros per year is in general a good thing, but what can I buy for these 100,000 euros? And this, of course, is depending what is the price level in my economy. Is it really a large amount? Is it really valuable, these 100,000 euros? And in opposite, the nominal variables, they are just measured in money units. They are all measured in euro or in US dollar. So then we have the nominal wage, the nominal interest rate. Compare again the Fisher relation, where we had the same concept. And now the price level is relevant. And the classical dichotomy means that if this quantity theory of money, this equation sign, really holds, that then we have an independence between these real and nominal variables. We have a decoupling. And this is called the neutrality of money. That money is only this good of exchange in between the exchange process of, in the end, the real physical units. And then we formulate that somehow money is just a veil. And there's also one very famous thought experiment by Adam Smith. Maybe you have heard of Adam Smith in school, one of the fathers of modern economic theory, UK Scottish guy in the 17th century. And he made the following thought experiment, that in UK you have red pennies. And let's say for 4 pennies I can buy a bread. And then he made the thought experiment. Well, let's just change overnight only the color of the pennies from red to green. And we are just announcing that now the green pennies are twice as valuable as the red pennies. So that overnight we are just doubling the income of every person. This is the thought experiment. And then he asked, what will happen? Everybody in the UK should have overnight the double income compared to the former day. And then think of the situation. You have talked in microeconomics about this, a positive dependence of demand on income. The higher my income, the more I'm demand. And then he asks he asked, does really something happen if only the color changes and we just announce everybody has the same, has a double income? Well, and then his argumentation was, and this is then called this neutrality of money, that he said, well, it happens nothing. The only, or not nothing, the only thing which would happen is that prices are doubling. And the argumentation behind this is, well, yesterday I could buy a bread for 4 pennies. Now everybody has the double income. So in general, if prices wouldn't change, I could buy 2 breads. But also the bakery knows that everybody has a double income. And so the guy in the bakery just says, well, I know that everybody now today can afford to buy a bread for 8 pennies. And so I change only the price of the bread from 4 to 8 pennies. So I have changed the nominal variable, the nominal amount of money. I just doubled it overnight. But this has, due to this argumentation, no impact on real variables. There will be no more bread. And this is this, yeah, very famous argumentation. Well, and then again, as always, when we argue in this theoretical way, we have to ask ourselves, do we find this in practice? Well, and in practice, I have glasses. I don't know if you are, if other guys here wear also glasses, and then you have a difference that some are myopic, so you can you have to change via your glasses that you look in the short distance, and for me it's for the long distance. And what we find is that in our economic behavior, we quite often behave so-called myopic, only in a short distance. So that if we hand overnight to everybody 100 euros, that in the short run, we really see that we do not follow this argumentation. Well, everybody has 100 euros more, so I can just increase the prices because of this myopic behavior. We obtain in the short run a little push on real variables so that we really start to buy more. And this actually was done in the financial crisis in the end of 2008, 2009, especially in the United States. There we had a cashback from the financial institutions to every US citizens of roughly 300 or 400 US dollars. And this really pushed in the short run the real variables. But on the other hand, in the long run, we should not be surprised that in the end, just prices will start to rise. And this different views, does nominal variables have an impact on real, or are they decoupling? This is just also the different view of the Keynesian view, where we said in the short run, prices are sticky, they are not directly adjust, and in the long run, they can adjust, and this is the neoclassical view. Okay, and now 50 minutes left. we want to talk a little bit how is money coming into our economy. Of course, the starting point is the central bank. Of course, it is a general institution of the country, but it is also just a bank, and therefore we just look at the balance sheet of our central bank. And there we have then, of course, assets and liabilities. And on the liability side, we have our cash money, our currency in circulation. And then we have the so-called deposits of the domestic banking sector, and this is especially the so-called minimum reserve. So we have a law that the private banks cannot hand out all their liabilities as credits. They have to hold a minimum reserve. Right now, it is 1% of the overall balance sheet. So this is then also a liability in the central bank. Then we have also some other liabilities. And on the other side, we have the net holding of foreign reserve, especially the ECB holds a huge amount of US dollar because unfortunately, nowadays I say unfortunately, we have to have US dollar since the United US economy is the most powerful one. Also, still, we have some gold reserve, but we have no gold standard anymore, as I argued already. Then the central bank gives out credit on the domestic banking sector and some other assets. And of course, this monetary base can just be changed if we increase cash money or especially if we change the net holdings of foreign currencies. So this is, so to speak, the base, the anchor of money with which we are starting in our economy. And now the commercial banks stepped in. Well, what are we doing? We do not spend always our whole money every day. We have our banking accounts. So we give some money to the banking sector, to our private bank. And what are they doing? They collect, remember the circular flow, they collect all this money and they hand out credits. Well, you give the money you are not spending today, let's say for 1 or 2 years, to the private bank. The private bank takes its money, creates a credit, and gives out a credit to a second person. Well, then this second person has cash money, obtaining a credit of, let's say, 10,000 euros. You can now, if you have on your banking account only 500 euros, you can now go to your private bank and ask, can I get a credit because I want to go to holiday of 1,000 euro or something like this? And then you can spend this for holidays. So then this money coming out of the credit is used as money. And therefore, of course, it is money. So handing out this credit will then appear at a first step as a deposit at another bank. And remember the definition of money. The sum of all overnight deposit in the private banking sector is relevant for M1. So via this process, in the private sector, money is created. And this process goes on and on and on. And this is called the multiplier process. Well, this process could go to infinity, but it is restricted, and this we will see in a minute, via this minimum reserve. Because if a bank would be able to give away 100% out of his balance sheet, then this bank would get 1,000 euros from you. It gives 1,000 euros as credit as a second person. This is a banking account of the second bank. So we have 2,000 euros cash. Then this could be to the third person and so on. And adding up infinite times 1,000 euro would be also an infinite number. But we will see it that due to this requirement of a minimum reserve, this amount will not go to infinity. In general, well, I said in the European Monetary Union, right now it is 1%, but in general, the private banks hold a little bit more than this by law required minimum reserve. And what is the reason behind this? Well, if you have your private overnight banking account, then you have always the right at any time to go to your bank and get your money back. And then the private bank thinks or calculates how many of my customers will come tomorrow and want to get their money back. Not everybody will do this. So some amount of this private money I don't need to have in cash tomorrow. I can hand it out. But I have to keep a relevant amount in my bank because somebody can come tomorrow and ask. And if I have no money, then my bank will crash. This is then called a bank run. And actually, 10 years ago, we had this situation in Cyprus. Because there was a great instability in the economy in Cyprus, also due to their relation to Russia, especially in 2015, when the Crimea War was. And then the people in Cyprus, they really went to their banks and they want to see, is there really the money? Or do I have only here a written paper where it says it should be there? So in general, these banks want to insure against such a bank run. And 2 years ago, the Nobel Prize was given to two guys who modeled what initiates a bank run. And also, maybe you have heard of it, that at 16th of September in 2008, Lehman, the sixth largest investment bank of the world, overnight collapsed. So everything was gone. And after this, there was a general fear in the global financial market that after one of the largest banks collapsed overnight, so all your money was back, was gone, that we are in a situation that we come to a global banking run, and this would have meant that the global financial system would have collapsed. Okay, so this is the argumentation why we have there why we are not handing out 100%. And let's do it with a little example. So think of the situation where the first commercial bank holds deposits worth 1 million euros. And let's say we have a reserve requirement of 10%. Then let's make this a little bit smaller here. Then we have bank 1 with 1 million euros. If we have a reserve requirement of R equals 10%, what would be then the amount of credits this bank can hand out? If I hold back 10%, yep, 900,000. Then credit of 900,000 euro. Well, this credit goes to a second person, to another person. And now we assume this person has a banking account at another bank. Let's say at bank 2. Then we have deposits at this second bank of 900,000 euros. Again, let's assume all banks have the same reserve requirement. How much credit would this bank hand out? 810,000, right. Again, this goes to a third person having a banking account at the third bank. There occurs deposits worth 810,000. Again, let's do it once more. 10%. Yes. 729,000. Well, these are all overnight deposits. Definition of money, summing up all these deposits, is the total amount of money. Let's assume theoretically this takes time, infinitely times this process is repeated. So then aggregate amount of money is equal to 1 million plus 900,000 plus 810,000 plus 729,000 plus and so on and so on. Will this be infinity? We are adding up an infinitely number of amounts of money. Or do you remember what kind of series we have here? Well, let's see how we have obtained these numbers. This was 1 million times, and now I write here 0.9 for 90% to the power of 0. What is some number to the power of 0? This is defined as 1, no matter what the number is. So this is just a 1. Plus, how did I obtain this 900,000? I obtained this via 1 million times 90%, so times 0.9 to the power of 1. how did I obtain 810,000? 900,000 times 0.9, but 900,000 was created by 1 million times 0.9. So this I obtain via 1 million times 0.9 times 0.9. So 0.9 to the power of 2. And this one, then 1 million times 0.9 to the power of 3. And so on. Here I always have 1 million. This I can take out the brackets, out of the brackets. 1 million times 0. To the power of 0, to the power of 1, 2, and to the power of 3. And now, do you remember what we have here? A series, and how is it called, this series? This is a special series. Huh? This is the so-called geometric series. I think you have had this in your introductory math course, yeah? So this is in general 1 plus q squared plus q to the power of 3, or sum of q to the power of n. M is going from 0 to infinity. And from this we can show that this is just a finite number, 1 over 1 minus q. So q in our case is 0.9. So this is just 1 over 1 minus 0.9. This is 1 over 1 over 0.1. And so this is just 10. So via this money creation process, I take central bank 1 million. Let's assume that this 1 million comes from the central bank as the first bank. It is circulated into the private market, and via this multiplier process, via this revolving credit process, out of this starting 1 million, I obtained 10 times my starting money. Well, and this 0.1 is nothing else than my R. So the number here is just 1 over R. So the amount of money via the private sector is leveled by 1 over the minimum reserve. And this is then called the money multiplier. And you see, if this number is not 10%, but it is 1%, then it is leveled by a factor of 100. And yeah, this is then the general money creation process. Oh, I could have done the calculation here. Let's delete this slide. Oops. And here we have this in general, not with the 1 million, but with the general reserve of R. And in the end, oh, this should be a large capital R. In the end, we have the starting amount of deposits divided by the reserve requirement. This is then the money multiplication process which we have here. Yeah, and then this is then for tomorrow when we are going to the monetary policy. Well, if you give me just 1 minute, why, maybe you have done this, why is this a finite number? This you can heuristically derive if you say, well, we are starting just with the square of length 1. This would be my starting amount of deposits. And now let's assume R is 50%. What would this mean? That the second area in the process would be just half of it. The next would be again half of it. And again half of it. Well, I'm adding up infinitely new areas, but I think you see here graphically, in the end, only a second additional square will be if I have this requirement here of 50%. So, and what do we have? 1 over 1 minus 1 minus 1 half is just 2, the area of 2 squares. Well, and then I think also you can think, well, this works also if I write here 30% or 10%. Only the area will be a little bit larger. Okay, so thank you very much, and then see you tomorrow.